Welcome to CS101 Introduction to Computer Science. This is the class about programming in Python. So what is Python? Right? It's a high-level general purpose programming language, kind of like Java, but not quite. It's unlike Java in the sense that it's interpreted, in the sense that the programming language is run on an interpreter. It doesn't need to be compiled into machine code, though oftentimes these days interpreted languages are often compiled into machine code behind the scenes for efficiency. It's dynamic in the sense that you can execute some programming behavior that static programming languages such as Java can do, like extending objects and definitions, modifying the type system, running evaluation on strings, and a whole bunch of other things. So here's some sample code for a Python program that lets you guess your number. The idea is that, so let's just run through this very quickly. In line 3, you initialize a variable that counts the number of guesses made. In line 4, it gets the input from the user asking them what your name is. Line 5 generates a random integer between 1 and 20, and it prints out a message saying that name, which is the user's name. I'm thinking of a number between 1 and 20. And line 8 to 16 are a loop, which we saw earlier in Java as well. Java and other programming languages also have this. So while guesses made is less than 6, in line 9, it asks the user to take a guess, and it takes that input from the user and converts it to an integer and puts it in a variable called guess. It increments the guesses made, so now it becomes from 0 to 1, right? And as it goes through the loop, it keeps incrementing the number of guesses that have been made. And if the guess that the user has made is less than the random number, it says the guess is too low. If it's greater, it says the guess is too high. And if it's equal to the number, it says, it breaks the loop and goes to line 17. So this loop is going to repeat 6 times. Lines 8 to 16 are going to repeat 6 times and allow the user to keep guessing numbers. And if the user guesses the number, it breaks, goes to line 17. It checks whether the guess is equal to the number and it says, good job, you guessed the number. Otherwise, if the guesses made are over 6 and it's come out of the loop, it's going to print like, oh, you didn't guess the number the computer was thinking of was so and so. So you can save this file that you just saw in the previous slide as some Python file. You open up, if you're on Mac, you open up terminal, navigate to that directory, run that command python some file name .py, and it will execute the file. You don't need to compile a program like you would in Java. You just run the Python file, and you can actually run this program on your command line. So Python is similar in some ways to Java. It's similar except for the indentation. Instead of curly brackets, you have to use space in Python to differentiate code blocks. Equal is the assignment operator. Math operators are the same. There's a power off operator, if else for conditionals. There are for and while loops. There's exception handling in the sense that if an exception is thrown in the middle of the program that the programming language that the program can catch, you can catch it using try except in Python. There's a class statement for defining classes. You can import classes, and you use def to define a function. So it's very similar to Java, except there's some semantic differences. There are also differences. So logical operators are expressed in English keywords and or not instead of and, the pipes and the exclamation mark. There's a thing called list comprehension. There's list and tuples, which are basically arrays, mutable and immutable arrays. And there's much easier ways to get an operator on arrays in Python, to get the first element, to get a subset of elements, to get from the start to the end element, and just get the end, like last few elements. This is a very powerful feature in Python, and it lets Python be less verbose, so have less characters, be able to build a program that works on data structures much more easier. So if you ever hear that people code a lot in Python for simple scripts, this is the reason. It enables you to build really simple programs with data structures, complicated data structures pretty easily. Indentation and spacing. So if you look at this Python code on the right, notice that there's none of the curly braces or semicolons that you would see in Java. There's just neat spacing, and Python relies on the indentation to parse the code rather than curly braces surrounding code blocks blocks of code are separated by the same sort of spacing that lets you see, easily visualize, and allows the program to easily compile what's going on. Makes it easier to read, and the number of spaces here doesn't matter, but it must be consistent across the program. So it could be spaces or tabs, but it just has to be consistent across the program. Variables. So unlike Java, you don't assign a particular type to a variable. So you can just do a equal to 1, b equals to name, and Python uses something called duck typing, where it derives the type of the variable. You can delete variables, and internally Python does have its own types for number, string, list, tuples, and dictionary. But again, it uses duck typing, where instead of you defining what a variable is, Python tries to derive it itself, whether it's a number or a string or a list or a tuple or a dictionary. That comes with its own advantages and disadvantages, but that's how Python is set up. And strings, so you can specify a string in single or double quotes. You can string subsets using the slice operator, and you can add strings, repeat it. And again, if you look at this piece of code on the right, you can it basically gets a slice or subset of strings, and you can do some pretty powerful things with strings, just like you can do with arrays. And this is kind of where the power of Python comes from. So you can see how in this example program on the right, you can get subsets of a string and do some interesting stuff with it. Lists and tuples. So lists are mutable arrays, tuples are read-only arrays. Lists are represented with square brackets, and tuples with the circular brackets. Operations on both are very similar to strings. There's a slice operator and the colon, and you can concatenate, which is join multiple lists and tuples together, and also repeat them. So you can see again on the right, you have 2 lists, and you can do interesting things like print the first element, print a subset of elements, print the last elements, join 2 lists together. Dictionaries. So it's very similar to Java's hash map. Dictionaries, also called associative arrays or hashes or hash tables in other languages. And what this does is it's similar to arrays, where you have a list of elements, except that here you can use a dictionary to look up one value from the other. This is very useful for as building key value pairs, where you have a key, which is usually a number or a string, and a value, which can be any object really. So you use that key, so you know the key, and you use the key to get the value. So you can see this example where there's a list of keys associated with values, and these are enclosed in curly braces. Dictionaries are very useful in programming in general. They're a very fast, efficient sort of data structure. We won't go into more examples here, but just remember that if you ever program in real life, you will almost always use these associative arrays or hashes or hash maps or dictionaries. Operators, it uses the same operators as Java: plus for addition, minus for subtraction, star multiplication, slash for division. Logical operators are the English words and, or not. There are membership operators, where you can check whether an element is in a collection or not in. Here's an example of the in and not in sort of operator. So you can check whether an element is in a list or not in a list. And for decisions and loops, so you can use if-else. If a certain condition, then do something. You can do for while loops, like for iterating over an array. You can pass, which is an empty statement which does nothing. This is actually needed in Python because there's no way to have a empty code block because of the spacing. There's no way to do that. So Python has this no operation or no op operator, which is basically pass. So that's the only way you can have an empty code block with nothing in it. And this is from tutorialspoint.com. So basically, this is a program that iterates over each letter in the word Python, and then if it checks whether the letter is H, and if so, it will print that this is the pass block. So it's just printing an extra thing, and it prints the current letter, and then it prints goodbye. So you can see that it outputs PYT. This is a pass block, HON, and then goodbye.